Hello everyone. So I hope you all have done well in the GATE examination, the GATE 2024 examination for architecture and planning. So the initial response from the students is generally that the difficulty level of the question paper, it is not too difficult and it is not too easy as well. So the general response is that it is of a medium level question paper, which has fair number of questions of easy level 2 in it. So that's the initial response. And other than that, this particular session, we will be looking into some memory-based questions from the GATE paper, from this year's GATE paper, which we have got from inputs from our students. So we'll be looking into some few number of questions because we still have a week of time for the 1.5 week, at least 2 weeks of time for the response sheet to be out. So that's the reason we are going to discuss some memory based questions in this particular session. And as we get more number of questions, we will try to put out more videos. And once the response sheet is out, we will be having a full length discussion of the question paper with respect to the expected cutoff and further details. As I told you, the initial discussions point towards not a very low cutoff for sure because it's not a very difficult paper as such. So if we look into some theoretical and also some numerical questions in this session, starting with this first one. They have given four options. It's based on landscape architecture. It's a multiple select question. The four options are given and they're asking us to select the correct options. So four different, say, the botanical names of plants are given over here. The first one, they are so the Kadamba plant. They are talking about cone-shaped poisonous fruits, which is not correct because this Kadamba plant actually does not have poisonous fruits and also does not have cone-shaped fruit for sure. The next one, Plumeria alba, is a flowering shrub. That also is not a correct option because it's a tree. Hibiscus flowers of red, pink, white, or yellow color. That would be a correct option. And also Delnex regia would be having is a flowering tree, and that also is a correct option. It has those flame colored flowers. So C and D would be the appropriate answers. Now I'm telling you that these are just memory based questions. The official question paper is not out, so there could be a possibility of some options be so which we are showing over here. It might not be the exact one, or the question might not be exact same as per the question paper. Once the response sheet is out, I told you we will be having an in-depth discussion of the actual question paper too. The next one, select the correct option for oxidation pond. Oxidation pond is a type of aerobic digestion process which is used in wastewater treatment. So it is also called a stabilization pond, where you have open ponds which are open to sunlight. In the presence of sunlight, the aerobic bacteria will digest the waste, the organic waste present in the wastewater. So it is not an aerobic process and it does require sunlight, so that's also an incorrect option. It doesn't reduce the BOD of water, wastewater. Obviously, it will reduce. What is BOD? It is a measure of organic pollution. And oxidation pond is a type of treatment. So this is used for wastewater treatment. And in wastewater treatment, the focus is always to lower the organic pollution and reduce the BOD of it. So that also is incorrect. It doesn't reduce BOD. That would be incorrect. The correct option over here would be it is an aerobic process because it is oxidation. In the name itself, it is written. It's an oxidation pond. That is something which is done in the presence of which happens the digestion process, which happens in the presence of oxygen. The bacteria would be decomposing the waste present in the organic waste present in the wastewater. So that would be the answer. B would be the correct answer for this question. The next one, there were different types of educational facilities, and this is based on URD-PFI guidelines directly. So as per URD-PFI guidelines of the social infrastructure for different educational facilities, what is the population served per unit? So I have matched it already over here, but it was given in the form of match the following. So now it is a simple, even if you don't know the standard, you can actually try to select the option by looking into the order in which it grows. So generally for primary school, you have the lowest level of population served of 5,000. For college, ranging up to 1,25,000. So you can arrange it in that order and see which option will match that. Or so college, the population served is 1,25,000. Integrated school, the population served is 90,000 to 1 lakh as per UIDPFI guidelines. Senior secondary school, it is 7,500, and for primary school, it is 5,000. That's about the population served for different educational facilities. The next one, this again is a theoretical question where they ask which of the following has a bow-shaped layout. So bow-shaped layout or bow-shaped network of so this is based on Vedic town planning. Uh, so which is Karmuka layout? So that would be the answer for this question, which is known to have a bow-shaped layout in the Vedic town planning principle. The other ones like Nandyavarta, Dandaka, these have a grid layout with rectangular intersecting street patterns. So Karmuka would be the answer for it. Let us also look into some numerical questions which have been asked in the paper. It is a mix of all common architecture and planning probably. So the first one, if you see over here, the present value of the building is given. The initial value or the present value is given as 50,000 rupees, and the salvage value at the end of its useful life, that is given to be 50 value, 15% of 50,000. You can use your calculator, so it is coming out to be 7,500 rupees. That's the salvage value. So from this, you can find out the what is being asked. They're asking us the book value after 3 years. For book value after 3 years, they have stated to use straight line method, or they have mentioned using arithmetic or equal amount deducting every year. So that basically straight line method. For that, we can first calculate the total depreciation, and the total depreciation will come out to be 50,000 minus 7,500. So you can write it to be 42,400, 42,500 rupees. That's the total depreciation. Now from this, you can calculate the annual depreciation, that is depreciation per year. Annual depreciation is equal to the total depreciation of 42,500 divided by the number of years, that is 5 years. So that's going to give you 8,500 rupees per year. Rupees 8,500 per year. Now we need to find out the book value after 3 years. So book value after 3 years will be the initial book value is always the initial value minus the accumulated depreciation. The accumulated depreciation will be for 3 years, 8,500 each year. So 50,000 minus the depreciation of 3 into 8,500. You can calculate it would be so the depreciation is coming out to be 25,500. So if you subtract that from 50,000, you will get the final answer as 24,500 rupees. That's going to be your answer for the book value after 3 years. So that's a very simple, straightforward, straight line method of depreciation based question. So moving on, let us look into the next one as well. This is a question based on ramp. So a ramp slope 1 is to 12 is provided for a height of 900 mm, and they have also mentioned that landing of 1.5 meter length is to be provided after every 9 meters. The total horizontal length of the ramp they are basically asking. So firstly, just applying the formula for slope, which is nothing but rise upon run. Now, as I told you, the numbers or the given information or the wording or what exactly is being asked, all those can slightly vary once the official paper is out. We'll have a actual discussion on the paper. This is just memory-based questions from the initial input. So the ratio between rise upon run is given to be 1 in 12. The rise is given to be 900 mm, so that's 0.9 meter. So this implies, if I write it in meter, 0.9 meter upon run is going to be 1 in 12. This implies the total horizontal distance run is going to be 12 into zero point 0.9, which is coming out to be 12 into zero point 0.9 is coming out to be 10.8 meters. Now, in this 10 point, now you need to see if this 10.8 meter, is it crossing 9 meter? Absolutely yes. For every 9 meter, you need to provide a landing. So the ramp is going to be this way, first 9 meters. Then you would be having a ramp landing of 1.5 meter landing. Originally this 9 meter. And the remaining after 9 meter, you still have a ramp left out of 1.8 meter. So that also has to be added. So what is the total horizontal length? It is 9 meter plus a landing of 1.5 meter plus the remaining portion of the horizontal distance of the ramp. So, or in simple words, you can say 10.8 plus 1.5, you will be getting it as 12.3 meter. That's the horizontal distance of the ramp. Based on if this is what exactly they have as horizontal length, then the answer will be 12.3. Based on the wording of the question, the answer could be different as well. So that was a simple question on the slope calculation of a ramp. The next one, uh, the auditorium. So this again is a question from the common part, most probably a numerical. Um, Auditorium with a capacity of 1200 people, with one third females and two-third male, are to be considered, and there's a requirement. What is the total WC water closet requirement they're asking? And it is given that the female for the female washroom, the requirement is 3 for every 100. The first step, so they have given for every 100 you need to consider 3 WC. After that, it is 2 WC for every 100 for from 200 onwards. Similarly, for male also they have given some standard. You need to look into the information carefully. I think it was 1 for 250 after 400. So that is important. Don't do a mistake over there. Let us try to solve this. Firstly, we need to find out what is the female population and the male population. So female population, let me write. Female population or female, they to be served by the washrooms, that will be 1200 into 1 by 3. One third of 1200, that's going to be 400. Similarly, if you look into the male proportion, it is two-third. So out of 1200, if it is two-third, that's coming out to be 800 persons. Now for 400, first let us try to solve the female population or female part. It is 3 for every 100 up to 200. So it will be 3 for the first 100 plus 3 for the next 100. So up to 200 we are done with 3 plus 3, and 200 onwards it is 2 for 100. So 2 plus 2. So initial 100, 200, 300, 400 population. The total number of WCs required for the female portion, that would be uh, 10 WCs. Similarly, for the male part of the population, the WC required is going to be, it is 2 for every 100 up to 400. So it's going to be 2 plus 2 plus 2 plus 2 for the first 400 people. And after 400, it's going to be 1 for every 250. So that I'll add one more for the next 250. So we are reaching to till a population of 400 plus 250, that is 650. You'll need to provide one more because we need a total of at least 800 you'll need to consider. So you cannot provide a fraction of WC. So you'll need to add one more to go beyond 650. So obviously it will cross 800, but you'll need to provide that also because you'll need to give an answer in integer only. You cannot give a fractional WC. So this, if you add up, you will get uh, 10 again. The total number of WCs will be total number of WCs required are going to be 10 plus 10, that is 20 WC. So 20 is the answer for this question if this is the given information for the given say numerical. Let us also look into the next one. Now this is based on structural analysis of a beam. They have given a beam with some particular loading. Some part of it has a UDL. There are 2 point loads. The total span, as you can see, it is 6.5 meter span. And they are asking us what is the maximum hogging moment in this beam. So hogging moment is nothing but, in other words, you can say negative bending moment. Generally, we take sagging moments as positive and the hogging moments as negative. They're asking us the negative bending moment, so you need to give an answer. If it is a negative answer already, you will need not write minus again. So let us try to solve this. First thing first, in finding out the maximum bending moment, the easiest way would be to draw the shear force diagram, bending moment diagram, and have a look at it. That way, you can easily give an answer. So, in order to draw SFD BMD, you should first solve the unknown reactions here. So let me mark the points. Let us say this point A, this is B, and let us say point C is somewhere, or say probably this is C, D, and E. You'll need to first find out the support reactions. Let me consider the support reaction over here. This is RA and an upward reaction RD. So if I try to solve these support reactions first, By using the equilibrium equations, I will get RA plus RD is equal to total loading upwards should be equal to. So this is applying this equation of summation of forces along the y direction, vertical direction to be 0. So if I apply that, I will get RA plus RD will be equal to T plus for the UDL it is 2 into 2, 2 kilonewton per meter over the span of 2 meters. So it is 2 into 2 plus 5. So this is going to be 12 kilonewtons. That's the first equilibrium equation. If I apply second equilibrium equation of summation of all the moments about point A, you can always take about any particular support, it will make the calculation easier. So if I take it about support A, I'll get the equation to be 3 into 1. That's a positive moment. So I'll take it as plus because it's clockwise moment. Then you have the next one, the so you consider the UDL to be a point load acting at the center of the UDL. That's going to be 4 kilonewtons acting at a distance of 3.5 meters. So 4 kilonewtons multiplied by the distance till the centroid is going to be 2.5 plus 1, that is 3.5. And that also is a clockwise moment, so I'm going to take it as positive again. Then there's a negative anti-clockwise moment due to RD, so I'll write it as minus RD into the total distance is going to be 4.5. And finally, 4.5 it is. And finally, there's 5 kilonewtons creating a clockwise moment, so it is positive 5 into the total perpendicular distance is going to be 6.5. That sum should be equal to 0. Now, if I simplify this, I will get 4.5 RD is equal to the remaining part, that is 6.5 into 5 uh, plus 3.5 into 4 plus 3. That's coming out to be 49.5. So minus and minus gets cancelled, so I'm not writing that again. So this implies finally RD is equal to 49.5 divided by 4.5, which is coming out to be 11 kilonewtons. So that's the reaction at the support D. Now, if that is 11, the reaction at support A will be 1 kilonewtons. So this implies reaction at support A is going to be 1 kilonewton. So we have solved the support reactions. That's the first part. Now let us draw this FDBMD quickly for this particular beam. If I'm considering, let me draw the beam over here. There is an upward reaction of 1 kilonewton at point A. Then this is say point B, and there is a loading, external loading of 3 kilonewtons acting at this point. Then you have point C, and this is point D, between which you have a UDL of 2 kilonewton per meter acting on the span. That's 2 meter span, and then there is an upward reaction at this point D as well. Let me write it as upward reaction of 11 kilonewtons. This is point D. And finally at point E, there is a force acting in the downward direction of 5 kilonewtons. So that's the beam after solving for the support reactions. If I write down the spans to here, this will be 1, this is 1.5, this is 2, and this is also 2 meters. That's going to be the span. First, let me draw the SFD, the shear force diagram. For that, I'll be using the loading diagram as the reference. So the shear force diagram first. You have a 1 kilonewton of upward reaction acting at the point A. So that will be positive plus 1 kilonewton. And that's constant till the point B. So it is constant of 1 till this point, it is 1 kilonewton. At the point B, there is a downward loading of 3 kilonewtons. So it would be reaching minus 2 over here at point B. This is A. And then you have no loading till point C again. So that's going to be straight line till this point again. Between point B and point C, there's a straight line. Then from point C till point D, This is point D, and this is, let me mark it as C, point D. Between C and D, so you can use this simple calculation. The distance between, or the final shear force at point D will be area under the loading diagram. Shear force at D minus shear force at point C. That's going to be area under the loading diagram, which is minus 2 kilonewton per meter into 2, which is minus 4. So shear force at point D minus shear force at point C, we are already at minus 2, right? So this implies shear force at point D is going to be minus 4 minus 2, that will be minus 6. So you'll be reaching to minus 6 from this point, and the nature of that curve, so at point D it is going to be minus 6, and that minus 6 is going to be a curve which is negative and constant because it is a downward load, so it's going to be negative and constant slope, minus 6. So this is minus 6 over here. Now, between D and E, again, there is nothing acting between, so actually at point D, there's an upward reaction of 11 kilonewtons. You'll need to also consider that from minus 6, it would reach up to plus 5. There would be a sudden jump in the SFD. That's going to be 5 kilonewtons. There is constant line and then a downward load acting at point T. So that's going to be the SFD, the shear force diagram. This is the positive part. This is the negative part of the SFD. Now, to draw the bending moment diagram, you can always calculate bending moment between any 2 points. Will be area under the shear force diagram between those 2 points. So you can, so bending moment at any given point, you can use it, you can calculate it. Similarly, like how we did SFD for the shear force diagram, bending moment final minus bending moment initial will be area between those 2 points under the SFD. So for that, let me, this has the reference line because they have asked the negative bending moment, this hogging moment. So there will be a positive and also negative part in this bending moment diagram that we know already. Let us say this is point A, point B, point C, D, and E. So So that's the reference line. Now at point A, there is no point moment acting over here. And then between point A, so bending moment at point B minus bending moment at point A will be area under the shear force diagram, which is 1 meter span and 1 kilonewton. So that's going to be 1 basically. So this is equal to 1. And bending moment at point B minus 0 is 1. Bending moment at point B, that will be basically 1 kilonewton meter. And what type of curve we'll be using? It is positive and constant curve. So it could be of this. Yep, so the positive part, and this is 1 kilonewton meter. And let me mark it with another color so that you can differentiate and remember the values because they are asking us that value. So this point will be 1 kilonewton meter at point B. Then let us do the calculation for point C. Bending moment at point C minus bending moment at point D, point B, is equal to area under the shear force diagram between those points, and that area is 1.5 into minus 2. So that's minus 3 basically. And bending moment at point C minus at the point B, it is 1 kilonewton meter. So bending moment at point C will come out to be minus 2 kilonewton meter. It is minus 3 plus 1. So it is minus 2 at point C. And what type of curve it is? Negative and constant. So to know the exact point where it is cutting through the axis, you can use similar triangles, but then that is not a point of information which we require in this question at least. So this point is coming out to be minus 2 kilonewton meter at point C. The next one, at point D now, bending moment at point D minus bending moment at point C is equal to area between those 2 points in the shear force diagram. So it is a trapezium. You can directly use that formula, or you can also add rectangle plus triangle area. So the rectangular area over there, that's 2 meter span. So 2 that rectangular area is going to be 2 into minus 2. That's the rectangular area. Plus the triangular area will be half into the base is 2 into the height is going to be minus 4 because it is minus 2 till this point. The remaining part will be minus 4. So that will come out to be minus 4, that is minus 8. And bending moment at point D minus bending moment at point C was already minus 2, that is equal to minus 8. So bending moment at point D will come out to be minus 8 minus 2, that's going to be minus 10. So we will be reaching to minus 10 over here at point D. This is minus 10 kilonewton meter. This probably could be our answer, the lowest point of our BMD. So what type of curve it is going to be? It is negative and increasing slope. Negative and increasing curve would be something like that. Mark this is negative. This is negative and increasing slope curve, which would be reaching to minus 10 kilonewton meter. And then finally, bending moment at point T, obviously it would be zero because that's a T end and it is positive and constant curve. So probably would be a straight line this way. So that's going to be the bending moment diagram for this. And they are asking what is being asked in this question. They're asking us the maximum hogging moment over here. So the maximum bending moment is coming out to be negative 10 kilonewton meter. That minus sign basically denotes that it is a hogging moment. So you can say a hog. The answer is going to be hogging moment. The maximum bending moment of this beam with that given loading is going to be hogging moment of 10 kilonewton meter. So you if because I have already mentioned hogging, you need not write minus again in this equation in this answer. So the final answer is going to be 10 kilonewton. So if they ask you what is bending moment, then the answer will be minus 10. But they're asking us hogging moment over here. So you can just write it as 10 probably. Now again, it depends on the wording as used in the question. But 10 kilonewton meter would be the answer if these values and this span is correct as per the question paper. So that was a quick explanation for that. The next one, this is based on the acoustic part. Uh, so again, this structures question, however, as per the official syllabus, it should be in the architecture part. But some of us students was telling that it is in the common part. You can actually comment into the chat of this video and let us know, was it really asked in the common part or was this a question in the architecture part? Also, if you have some other question you remember and you want, if you have any confusion on it, you can put it into the chat and we will try to accommodate it if we are having a next session or second part of this memory-based questions. We'll include as many questions as we can. Uh, However, we get a response sheet with the official question paper within a week of time once all the gate papers are done. So let us look into the next one. This is based on acoustics. They have given a graph over here for the decibel value on the y-axis and the time in seconds on the x-axis with a maximum of 110 and the bottommost point that is 50 decibel. Uh, they are asking us the total absorption of the room. So to calculate total absorption, we'll be using this equation. Reverberation time is equal to 0.6 into V by A. So that A is being asked, V is directly given in the question as 3500 and RT instead of directly giving the reverberation time, they have given the graph and you should know the definition of reverberation time. What is reverberation time? It is the time taken for the sound to fall 60 decibel below its original level. This is the formula for RT60. So 60 decibel below the original level, it falls down, it will reach to 50. And how much time is it taking? 2 seconds. So from the graph, you can see that the reverberation time for fall of 60 seconds is going to be 2 seconds. What is reverberation time? The time required for sound to fall by 60 decibels from its original level. So 2 seconds is the reverberation time. So 2 seconds is equal to 0.16 into volume is 3500 upon the total absorption. Sound absorption A will be equal to 0.16 into 3500 divided by 2. That's going to give us an answer which you can use your calculators to calculate. 3500 into 0.16 divided by 2 will give you 287. So the answer for this question will be 280 if those given pieces of information. That was a short session with few of the memory based questions. We'll try to add few more questions in the next session if possible. Uh, I hope this was useful for you to give you a bit of idea on some basic questions which have been asked in this year's question paper. In the description of this video, you will also have a link where you can give your response on what you think about GATE 2024 paper and how it was for you, the difficulty level, and for the details. It would help us release the expected cutoff in few days of time. So you can check out the link in the description of this video. And in due course of time, once the official paper is out, we'll have a full-end discussion. We'll give you full guidance on the cutoff, and we will also be scheduling the post-gate counseling session based on your gate rank in the future. So do stay subscribed to our YouTube channel and all our social media platforms. Thank you.